Welcome protein coders, let's build some coding muscles. Today we're gonna see a problem in DP on grids only, minimum path sum. This problem is available on Leetcode also as problem number 64. Okay, so let's see what's given in the problem. So we have to move from start to end and we need to find the minimum path sum. What is a minimum path sum? It's a path in which the sum of the total values will be minimum and we need to return this minimum sum. Okay, and we can move only in either rightwards or downwards direction. So we can have many paths, right? We have to find the minimum path sum. And one more thing, on first thought, maybe you can think of greedy, but greedy will not work here. Why? Because there is no pattern here, there is no uniformity here. We need to try all the paths, we need to check all the paths. And whenever we need to try all possible paths, all possible cases, we use recursion. So let's see how we're gonna implement this. So as always, we will move from the last node, last index, okay? And we have two choices, either we can move upwards or leftwards. And we need to reach index 0, 0. So for first case, what I will do, I will pick the value at that node, grid ij, okay, and plus for upward case, I will call the function recursively for the above cell. Okay, here solve ij represents the minimum path sum till index I comma j. Okay, similarly I will get for the left case, if I move left, then I will get the value plus called recursively for the left cell, and at the end I will return the minimum of both the cases, up and left. Okay, that's how simple it is. Let's write the recursive code for this. So let's write our function solve. It will take index ij and our vector grid, vector of vector. Now for upward case, we will call recursively for above cell and similarly for leftward cell, and at the end we will return minimum of up comma left and we will pick the value of the grid also. For the base case, when we reach index 0, 0, we will return the value of the grid. Okay, because the minimum path sum at index 0, 0 will be the value of the grid only. And for out of bound cases, we will return a very big integer because we are taking minimum and we need to reject this path. So let's quickly see the code part. Let's get the size of the grid n and m, and we will return our solve function. We will pass n-1, m-1 and grid. So let's define our solve function. First case for up and left, and at the end we will return, take the value of the grid at that point and minimum of up comma left. And for the base cases, first for out of bound cases, we will return a very large number, and for the base case, we return the value of the grid. Okay, let's quickly submit this, and congratulations, we got TLE. So we need to memoize our code. Okay, so let's see how we're gonna memoize our code. So if you observe carefully, our I value can go from n-1 to 0, and similarly for j, can go from m-1 to 0. So we need a 2D DP vector. Okay, so let's quickly update our code. First, let's define our DP vector of size n comma m and initialized with all elements with -1. Let's pass this DP vector everywhere. Okay, in our recursive calls also. At the end, we will store the value of the recursive call in our DP element, dpi comma j, and we will also put a check. If dp of ij is not equals to -1, we will return dp of ij. Let's quickly submit this, and yes, we have passed all the example test cases. Let's submit this, and congratulations, we have passed all the test cases. Okay, now let's quickly see the tabulation code, how we're going to convert our code into tabulation format. So in our memoization solution, we have moved from index n-1, m-1 to 0, 0. So in tabulation, we will move from 0, 0 to n-1, m-1, bottoms up, right? And our answer will be at the element n-1, m-1. So in our DP vector, DP of ij represents minimum path sum till I comma j. Okay, and from base case, we know that DP of 0, 0 will be grid of 0, 0, right? Minimum path sum to reach index 0, 0. Now in tabulation code, we will have two for loops, one for index I, one for index j, right? And dp of 0, 0 will be grid 0, 0. And if I and j both are 0, we will continue. and or else let me just copy the recursive relation here. Okay, wherever there will be a function call, I will write dp there, right? And dp of ij will be grid ij plus minimum of up comma left. And for the out of bound cases, we will insert a check here only. If I is greater than 0, then only we will take the grid dp element, or else we will return int max to discard this path. Okay, and after both for loops, we will return dp of n-1 comma m-1. Let's quickly see this in the code. So let's get the sizes first, n and m, and let's create a 2d dp vector. And dp of 0,0 will be grid 0,0 from base case, remember. Now let's write to our two for loops for I and j. If I and j both are 0, we'll continue, or else we will write for up and for left, and at the end we will write dp of ij will be grid of ij plus minimum of up comma left, and at the end we will return dp of n-1 comma m-1. Let's quickly submit this, and we have passed all the test cases. Now let's see how we're gonna space optimize this. Okay, so if you see our reconciliation in our tabulation code, then up will be dp of i-1j, left will be dp of ij-1, and current will be dp of ij. So here, when I'm calculating dp of ij, I'm just taking the minimum of upward element and leftward element. Okay, similarly, if I take any point, I will just need these two rows only. Okay, so what I will do, as we have solved in our previous problem also, unique grid problem, I will just use previous and current. Okay, so let's modify our tabulation code to space optimized code. Let's quickly remove our 2d dp vector and define previous and current. So let's define our previous m,0 size and current also. Let's remove this from here and let's write here. If I and j both are 0, current j will be grid of 0,0. And the same trick which we have used earlier also, for dp of i-1, I will write previous. For dp of I will write current. Okay, so let's replace dp of i-1 with previous, dp of I with current, and after the for loop, I will make previous assigned to current, or sorry, current will be assigned to previous, and at the end we will return previous of m-1. And let's quickly submit this, and we have passed all the test cases. Now let's quickly see the time complexity. For recursion, we have two ways, right, for every cell, and we have n cells, so it will be order of 2 to the power n. For memoization, we are filling our dp table, right, so time complexity will be m cross n. Space complexity will also be of order of m cross n. Similarly in case of tabulation also. But for space optimized approach, we have two vectors, right, of size m. So time complexity was same because we are running two for loops, but space complexity will be 2 times m. So that's all from my side, guys. You will find the problem and the solution link into the description box. If you have any queries and suggestions, please mention them into the comment box. I hope this helps. Let's meet in some other video. Till then, keep smiling, keep practicing. Thank you.